Hello everyone, here's a question based on chemical bonding. What is the total number of lone pairs of electrons on oxygen atoms of ozone is? The molecular formula for ozone is O3. We have 3 oxygen atoms. Atomic number of oxygen is 8. Therefore, the electronic configuration is 1s2, 2s2, 2p4. We have 6 valence electrons in each oxygen. So, therefore, 6 times 3 and that is equal to 18 valence electrons. Using 18 valence electrons, let us write the Lewis structure of O3. If we do that, then we can figure out the lone pairs of electrons. We have 3 oxygen atoms. Let us put one bond pair between 2 oxygen atoms on both sides. That accounts for 4 valence electrons. And then let us put 3 lone pairs on the edges. If we do that, then that would account for 12 valence electrons. So, 12 plus 4, 16. We still have 2 more valence electrons. Let us put that on the central atom. Let us write it this way: oxygen, one bond, another oxygen, and then one bond, another oxygen. So, we have 3 lone pairs here, 1 lone pair here, and 3 lone pairs on the edge. But this is not the best Lewis structure, isn't it? Because the central atom is not satisfying the octet configuration. So, if we count the total number of electrons here, we have only 6 valence electrons here. But on the contrary, on the edges, we have the octet configuration. So, let us bring a lone pair of electron to the bond pair. If we do that, then we would have the best Lewis structure, where all the atoms will be satisfying the octet configuration. So, oxygen, 2 lone pairs, a double bond, oxygen, 1 lone pair, and then a single bond, oxygen, 3 lone pairs. So, this structure satisfies the octet configuration. Now, we have 8 electrons around each oxygen. So, even if you calculate the formal charge for this, the net charge would become 0. So, here you will get minus 1, here you will, for the central atom you will get plus 1, and for this one you will get 0. So, the net charge is 0, therefore, this is the best Lewis structure. So, in the best Lewis structure we have 6 lone pairs of electrons. So, therefore, 6 is the correct answer here. And the way you can calculate formal charge is equal to total number of valence electrons in the atom minus total number of lone pairs of electrons in the molecule minus total number of bond pairs of electrons divided by 2. So, for example, if you calculate for this oxygen, then what would happen? 6 minus, we have 3 lone pairs. So, that would be 6 because we have 3 lone pairs here, minus we have 1 bond. So, therefore, 2 by 2. So, this means it is minus 1. So, likewise you can calculate the formal charge for the other 2 cases as well. So, 6 is the correct answer here.